right, number one. Kendall, start us off. So what's freefall?
Freefall is any falling object that is free to fall with strength and falls under the influence of gravity.
Good. I'm going to modify your words only slightly. So you said a falling object. I'm going to say any vertically moving object. So any vertically moving object affected by gravity and nothing else. So, affected by gravity, not affected by any other thing. Now, here's why I said vertical motion. The reason I said vertical motion is because this is for objects going up and down. So, free fall is a bit of a misnomer because it implies that it's just for falling objects, and it isn't. It isn't just falling objects. Okay? It's falling objects as well as vertically upward objects. It's even for objects at angles, but we're not ready for that yet. Okay? That's for you to look forward to for next evening. All right. Good. So we got that one. Trey, what about, yeah, can I ask you a question?
So if I'm jumping up,
Yes.
will I be free fall?
Yes. I know that sounds weird, but that is exactly what it is. Trey.
But free fall is supposed to be affected by gravity only. If you're jumping upward using muscles in your legs.
Not when you're going up. So to get you started, you're exactly right. But once you're in the air, the instant your feet are off the ground, then you're only affected by gravity at that point. Because the force has to be applied by something. Once you're off the ground, there's no something anymore.
So what about the what about like a bouncing ball then?
Yeah, so same thing. So as the ball's falling, it's free fall because there's nothing except gravity pulling on it. When it hits the ground, there's a force from the floor pushing up on it. Once it bounces off the ground, then again, it's going to be only gravity until it hits the ground again. So when we're in the air, it's only gravity, it's nothing else. Good questions. Trey, we'll stick with you. What does little g represent, and what's the value?
I said G represents an object's acceleration in the case of free fall.
Good. So we usually call it the acceleration of gravity. Technically, though, it's the acceleration due to gravity. And what's the value? Yeah. Okay.
9.8 meters.
Yes. So here's something really important. So first of all, your book uses the number 10 way too often. And I get why they use 10. They want you to just think about they want you to think about the pattern. The value is 9.8. We're going to use 9.8. It's not 10. Although technically in the state of Florida it's 10. They passed a law that gravity is 10 in Florida. So apparently you can just make gravity whatever you want as long as you pass a law for it. So we should pass one to make gravity 15 and just see what happens. Anyway, it's besides the point. I do want you to notice this. The value for G is not negative 9.8. We'll get into why it should be negative later, but I want to make sure you understand G itself is not negative. It is not a negative value. It is just a number. So G is actually a scalar because it's just a value. When we plug it into equations a little bit later, then it'll become a vector and we'll have to deal with direction. But for today, we're not worried about direction, so it's just a value. Yeah, Trey.
So does this number work for any free-falling object?
Yes, and we'll get to that in a second. But yes, it's any free-falling object. Yep.
So technically everything is falling at the same rate?
Yes. It is, but it won't be in a second. There's a reason why you don't notice that, right? Because, like, I think all of you would agree, if I drop these at the same time.
Well, that
Right, so we're going to talk about air resistance in a little bit. But that's the idea. Excellent. All right, we're cruising. Come over here. What about you? Number 3. So why do we use v equals g over t? And which of those 3 equations does that seem to be closest to? Mm-hmm. Yes. Yes. So the reason why we can use this is because the velocity is how much the initial velocity changed in an amount of time. So if I want to know how fast something's going, I just need to figure out what was the initial velocity, which we're assuming it's 0. That's why it's just gt. We need to figure out how much did it change. So if it accelerates at 9.8, then if this is for 10 seconds, then each second it gains 9.8. So at the end of 10 seconds, it'll be going 98 meters per second, in theory. And he's exactly right. The equation that fits best with is this one. So instead of a, we're using g. A is acceleration. G is the acceleration of gravity. And there's no vi because we're assuming we're just dropping it. So we're assuming we're not throwing it down. We're just letting go of it. And again, this is a little too simplistic, but for what we're doing today, it's fine. We're just getting the basic ideas here. All right, any questions on 1 through 3? There we go. Positive, negative, or 0 for the displacement as it's falling. Okay? And again, don't change your answers yet. I'm just putting the answers down that people have, then we'll go back and check them. Colleen, what about the velocity? Positive, negative, or 0? Okay? All right, Alexis, what about the acceleration? Positive, negative, or 0? Okay? And Justin, speeding up, slowing down, constant velocity, or at rest? Okay? All right, number 5. Gavin, what's the displacement? Positive, negative, or 0? Okay? Austin, what about the velocity? Okay? Macy, what about the acceleration? For number 5. Okay? And Jillian, what about what it's doing? Okay. All right, number 6. Timmy, what is the velocity? Okay. Timothy, what is the acceleration? Okay. And Zachary, what about what it's doing? All right. So let's go ahead and work through these. These are actually really tricky if you haven't thought of them before, which you probably haven't. So let's go ahead and look at these. So displacement is a change in position. So if I'm starting up here and my position is changing by going down, that's going to give me a negative displacement. So the displacement for 4A should be negative. The right answer is I'm going to put in orange. Okay? All right, the velocity. So if we are calling down negative, if my change in position is down, then my velocity is also down. So velocity is also negative. The acceleration is down. Gravity is changing by pulling it down. So this one is correct. It is negative. And as it falls, it will speed up. So that is also correct. So negative displacement, negative velocity, negative acceleration, and speeding up on the way down. Excellent. So on the way up, the displacement is positive because my position is changing upward, so that is good.
Velocity is positive because velocity tells me the direction of motion. That is also correct here. The acceleration is still down. Gravity is making the velocity change in a downward direction because gravity always pulls down. So it is a negative A. It's not a positive A. Even though the object's going up, the change is not up. The change is down. And on the way up, it is slowing down. Very good. So as it goes up, it gets less speed. All right, last one. This is the hardest one. So at the maximum height, what is the velocity? So I'm going up, I'm going up, I'm going up, I'm going up. I get to the highest point. I stop going up. Now I start going down immediately after that. That means that at the highest point, it is 0. At the highest point, it is not going up anymore, and it's not going down anymore. It's just stopped. Okay? The acceleration is negative because the acceleration is gravity, and gravity is still down. And if you think about it, this also makes sense from this perspective. So if I take this apple and I throw my apple into the air, okay? It's going up, it's going up, it's going up, it's going up. It gets to the highest point. If there was no acceleration, it wouldn't change. And since the velocity is 0 at the highest point, it would stop there, which would be awesome if that's how things work. You throw them up and they just go and get stuck. That'd be cool. But that's not what happens. It'll start falling. And because it starts falling, that means you're going to have a negative change. Even though the velocity is 0 at this point, your change in velocity is still going to be negative. And so what's happening to it at the highest point? It is at rest. At the highest point, the velocity is 0. The velocity is 0 at the max height. That is always true. So if you start at the max height, your velocity is 0 unless you're throwing it. But if I throw something up in the air, the velocity at the highest point, v final, at that point is 0, always. All right. Any other questions there? Okay, sweet. Let's jump to the backside. I'm going to show you number 7, and then I'm going to actually show a video for number 8.